Hello, ladies and gentlemen. So now we're going to look at example number 1. Now I'm going to tell you something right off the back. I'm going to do this exact question 3 ways. That's why it says method number 1 there. There's going to be a couple of different methods. Now first off, it's asking me whether or not both equations describe the same plane. The low-hanging fruit here, the easiest way to solve this question is if they don't describe the same plane. And if they don't describe the same plane, what you're going to find out is that the normals will not be scalar multiples. That's your low-hanging fruit. If you can prove that the normals are not scalar multiples, then you can prove that they are not coincident. So let's look at the normal for the first one. So R1, we'll look at the normal, is going to be given by 3, -2, 1, cross -6, 6, -1. Now we've talked about this. These are direction vectors. What's important is the direction, not the magnitude. So I'm going to make my life a little bit easier. I'm going to divide that by -3, which is going to give me 2, and it's going to give me -2. Oh, you know what? It doesn't make life that much easy. I'm going to get 1/3. Forget it. Don't like it. But there you go. Could do it that way, choosing not to. All right, let's do the cross. It's going to be 3, -2, 1, 3, -2, 1, -6, 6, -1, -6, 6, -1. Goodbye first column, goodbye second column. Down products. So it's down products, subtract up products. So it's 2 subtract 6, which is -4. It's -6 plus 3, so it's -3. It's 18 -12, which is 6. And that's got too many negatives for my liking, so I'm going to change it to 4, 3, -6. Let's find the normal for the second one. Well, I got to be able to pick out the direction vectors. The first direction vector is 3, -2, 1, and it's going to be crossed with the second direction vector, which is 4, -2, 2. This could be reduced. Don't think I care. Well, do I care? All right, I care. Let's change it to a 2, -1, 1. So now I'm going to be 3, -2, 1, 3, -2, 1, 2, -1, 1, 2, -1, 1. Goodbye, goodbye. Down products. -2, subtract 1, which is -1. Do I have agreement in the audience? -2, yeah. And then it's going to be 2 subtract 3, so that's -1. Then it's going to be -3 plus 4, so it's going to be 1. So I don't like all those negatives. So what would I have to multiply 1 by to get 4? I have to multiply it by 4. So if I multiply this by 4, do I get 3? Nuh-uh. So therefore, n1 is not a scalar multiple of n2, where k is an element of the real numbers. Therefore, the normals are not collinear. Therefore, these two equations do not describe the same plane, since they are not even parallel. Woo! Done. Do you have to put in all those words? You don't have to put in my words, but you got to put in words. I got to know what you're doing. Okay? That's a pretty neat question. Notice I could have gone off in all sorts of different directions there. I could have made this a really long question. I could have tried to find a point that they satisfy. I could have put x equals x, y equals y, z equals z. I could have done a number of things when this is all I needed to do. Keep your head about you. Think about what you're doing. All right, we'll stop here and we'll go on to the next one. I made a mistake. I said that I was going to do this 3 different ways. Yeah, I'm just doing it one way. It's the next one that I'm doing 3 different ways.